Let me record then. Yeah. Hopefully you didn't miss a lot in the beginning. But please feel free to open the microphone and ask directly. We really want to start writing the review paper. That's why I canceled the lecture for today, and we will have only focus on the review paper, just for your benefits. Okay. From reading paper, writing paper, it should really start from the undergrad program, where you have the research side integrated with the coursework. So that's why I'm going into those details, although you should already know about them in advance. But that is fine. I'm happy to do so. As we said, the introduction section, you are going to introduce what is the problem that you are trying to review. What is the application first? For example, if you are on read mapping, sequence alignment, you should define those terms. Briefly, the introduction is not about elaborating on the work. It's just briefly giving me the overall discussion of the entire paper. So I'm going to introduce briefly what is the application, what are the problems included in the application, what are the existing work, how they address, what are the directions for solving those issues. For example, there are 3-4 directions to solve the problem of large execution time and sequence alignment. What are those directions? So briefly give me a name, for example, for each direction, or what is the key idea behind each of those directions. For example, the first direction is to accelerate the algorithm by doing divide and conquer approach to solve the algorithm, or by doing dynamic programming, or by developing greedy algorithm, or by using hardware accelerators, or by reducing the computation and losing some accuracy but gaining more execution time. Just give me the idea behind each direction that try to solve the problem. Now, how we could know this information if we are not expert in the field? How we could know what are the existing direction to solve that problem? Now, there are different ways in doing so. The best method to do so is to try to read an existing artwork. Try to read existing artwork about the topic. What do I mean by artwork? So it could be a thesis or dissertation coming from a student who was a master or a PhD working on the exact same topic. Why we go for thesis or dissertation, although it can be 70 pages long or 100, 120, sometimes 200 pages. Normally the thesis, you can find a lot of details, a lot of figures, a lot of tables just about the topic that you are reading about. So you will not feel lost. You will not feel really abstract in terms of the information. You will get a lot of things just to elaborate on the key idea behind it. So you can go directly, normally chapter 2, you should have enough background on the topic, on the direction trying to solve the problem. So that is the best way to try to get something about the related work. Now, we are still in section 1, which is introduction in the paper. And as I told you briefly, you need to describe what each of those directions is doing. Now, the other artwork you could use is what we call review paper. So you are writing a review paper, but there are many existing review papers. And you can see some of them coming from me as main author for this paper, and some other coming from another research group. Definitely, you will see some review paper on any topic you choose. Normally, try to pick review paper coming from good affiliation and good venue, either as journal or a conference. There should be really good. And how you can define good and bad. So there's a tool in Google Chrome you could see. For example, if you are looking for good journal, you could use this plugin. You can see here. The name is Excitation. You can see this is the name, Excitation. Can you see it? It's here, Excitation. That is the name of the Google Chrome extension. You can add it to your Chrome browser and just add it. once you add it, whenever you open a Google Scholar for any researcher, it will rank the publication for you directly. So you can see this is quartile 1. It means this is among the best, the top journal ever. So you cannot see better journal than this. And you can see the impact factor next to it. You can see this is also, if you don't see as not defined or not known or does not exist, it means this is a conference, not journal. And that is the bad side of this tool. It only ranks journal, not conferences. But at least it solved half of the problem, which how do I know if this journal is good or bad? Okay. Now for conferences, I would say if you find the conference happening for at least 10 times, then it means the conference is good. Because normally, if the conference is done for business purposes, not for scientific purposes, normally after 2-3 rounds, people will feel that this conference is useless. We are not getting any benefit. We are not getting any questions when we present over there. So they avoid presenting next time during those conferences. So they will not come again, and that's why the conference name will be changed after 3-4 times. They change it to something else to hide whatever failure they had in that conference. And that's why if a conference really continuing for more than 10 years, it means really good one. People still coming to that conference to present their work. Okay, but there are also some other way to know if this journal is good or not. That is from Google Scholar itself. You can see ranking of this journal. For example, I want to see best journal in bioinformatics, and I want to have this information from Google Scholar itself. So Google Scholar provide that service for you based on the citation. So you can see list of any field, basically more around computer science, but you can see literally any field. So you can go to categories and you can see from here anything you want. And also you have subcategories. So you can choose, for example, engineering and computer science. You can go here, choose the very specific subcategory that you're working on. And then you will get a list of top journals, sometimes mixed with conferences. Sometimes you have conferences and journals, sometimes only journals. And it will be sorted based on the citation, how many times people cite paper from this journal or conferences. So that will give you also an idea if this journal is good, if this conference is good, and so on. But since you are working on bioinformatics topic, I would say that let me see if I can access this. I would say the best journal that you can deal with, first, bioinformatics. This is the name of the journal. This is coming from Oxford publisher. You have also genome biology. This is not in order, so I'm not sorting the list, but all of them are really good. Nature, anything. This include computational sciences. This include communications. This include methods. This include biotechnology. What else? Those are like the major venue that you could include from Nature related to bioinformatics and algorithmic development. So you can pick anyone from this. And then you'll get second tier journals, including BMC bioinformatics and maybe BMC genetics. What else do we have? We have also IEEE transaction, IT, I think ITCBB, maybe something like that, which is IEEE transactions on computational biology, and bioinformatics. I think those are top venues or journals that you can find, but you also can find some conferences, including Recomp, ISMB. What else do we have? We have also second group, ESPRA, IC CAPS. Those are top conferences. Those are second tier. This is second tier journals, and this is top journals. Those are the top venues that you can find for any review paper that you might use in your summary of those work. Okay. And once you summarize the direction for writing the related work in the introduction section, then you are going to introduce what you are going to do. Simply just say, we're going to critically analyze 4 state-of-the-art tool, 1, 2, 3, 4. You have to name them clearly. You have to say, this is the tool I'm reviewing, this is the name, and this is the citation. This is the name, and this is the citation. It's important to include both of them. Don't include just citation, because it will be just a waste of time. For me to figure out what you are reviewing, I have to go to that reference. I have to fetch the title from the reference list. I have to paste it in Google Scholar, look for the title, and then try to find the paper, and then figure out what it's about. For each tool in bioinformatics, normally there's a name. There is really a name that you can call the tool with. So include that name and then include the reference. This will make my life easier, the reader life easier, your life even easier, because even you yourself, you will forget what is this reference about. But once you have the tool name, whoever asking you about this reference 3, why it's bad performing, you will say, oh, this is the tool name, and I remember this tool does this and this and this. Okay. Now that's it for the introduction. That should not exceed 2 columns, and at most, let's say 2 columns and a half, which is a page and a half. It should not exceed that. Within 1 page, you should be fine with the abstract and the introduction. Please don't make your life difficult. Don't try to include a lot of details. This is not the place for the details. Introduction, it just gives me overall discussion about everything in the paper, not only related work, not only introduction to the application, but rather the overall discussion for everything, including related work, background, the application you are trying to solve, the problem, the key results that you may have out of the analysis, and so on. Now you jump to the background, the related work, and this is where you can include whatever details you want. For example, how read mapping works. It might work using 4 major steps. And the first step using indexing, the second is this, third is that, fourth is this. And the first one normally is done using this algorithm. This is the figure, maybe summarizing how it works. What are the details for having this application integrated with other applications? Maybe you can show some figure. We show the entire genome analysis pipeline with the sequencing, with the analysis, with some computer, with some sample collection. And within that framework for genome analysis, you show where this application is located. Is it with the sample collection? Is it with the sequencing? Is it after sequencing? Is it after base calling? Is it after the interpretation by doctor or before, and so on? So this is the right place where you can show all the details that you would like to have. It could be related work. It could be how the application works. It could be what are the main steps included in the application, and so on. You can include a lot of figures. You can see normally when you read more papers, you will see that this section, which is number 2, background and related work, is really repeated. Just duplication or replication of existing section from other work. Of course, you cannot copy paste. You cannot have the exact text and the exact figure in your paper, because you will have copyright violation, and then it will be plagiarized, and then you'll be banned from publishing again. And sometimes your university or institute will be informed about this thing that you did in your paper. So please be careful. Don't ever copy any text from anywhere as is. You are not allowed to do that, even if it is background. But what I want to tell you, that this background section, the same information will exist everywhere. In any other paper, you will see the exact same information, sometimes the exact same way of organizing the information in that section. So you will see like first subsection is this, you will see it everywhere. The second subsection everywhere, the exact same title, and sometimes the exact same content, but not the exact same text. Okay, so you'll see some rephrase with the text. You'll see some changes in the figure, like the way they sort the figure. Of course, if I ask any of you to draw a figure representing, for example, short read sequencing in Illumina, what is happening? Each of you will have different mindset, different imagination, different way of expressing those ideas. So it's really hard to see two researchers drawing the exact same figure. Okay, so there are ways how you make this section different from existing papers. But what I want to say, there is no really much of creativity in this section. There is no contribution basically in this. You can use any existing paper, rephrase it, or express yourself, write about how you understand this application, how it works. You could summarize a video explaining this application and so on. But you have to include some figures, make the writings nice, clear, direct to the point. Don't make too much sentences around the idea. Just jump directly to the idea. You have to clearly say the key insight, the key idea of this work. This application has 4 main steps. You have to clearly say those sentences. And that will be all for the first and second sections, okay? And then this is where you should be graded for, really. And this is where you should be evaluated for. Section methods. Methods mean what is the core contribution of each of the tool that you are reviewing. For example, I'm reviewing 4 tools. Okay, what is the first tool? Let's say KSW2, which is sequence alignment. Or let's say it's Bonito, if you are doing a nanopore base calling. Or let's say it is Minimap2, if you are doing read mapping. Okay. Now, what is the key idea of read mapping? We already go over a read mapping as an application, how it works in the background, but we didn't necessarily go over the details of each of the tool. Each of the tool might have its own steps, right? Although we already say that read mapping in general has 4 steps or 3 steps, and these are the steps. But when we go to each of the tools, you will see that there is something new, something different from one tool to another. And this where you have to express those differences in the method section. So in the method, you have to give always overview. Even in the writing, when you start writing, it's always good to go from the high level all the way to the low level details. Don't directly jump to the low level details. For example, don't ever say read mapping uses seeding or k-mers or subsequences to index them in a hash table. That is a detail. That's the low level details. What you would start with in the overview, in the way you write, in the introduction, in the background, everywhere, you should always start from the high level, meaning you have to say clearly that read mapping has 3 main steps. The first step is this, the second is this, the third is that. The main goal of the first step is this. The main goal of the second step is that. The main goal of the third step is this. And then gradually, you go over the low technical details for each of those steps. You can say the first step includes 4 other sub-steps, and those sub-steps works together to perform this goal. And this goal is done quickly and fast and efficient by having this method, and so on. And then describe what is underneath this method. So don't ever jump to the details of any paper directly. You have to give me the overview, the full overall description of the tool. Think about when you see an overview figure, for example, in any paper, you should see overview figure describing the method, how it works. For example, here, I'm describing how the algorithm works. And some other papers, especially if it has some component, you will see which paper maybe I can show. Yeah, maybe I can show you this This paper, the one I asked you to read about why we cannot sequence the entire, sorry, why we cannot sequence the entire genomic sequence as one piece. If you remember this paper, I asked you to read the obtaining genomic sequencing data and read the section that's related to sequencing. So for example, if this tool, this review paper, for example, about read mapping and sequence alignment. So of course, if you pick any of those topics, including also pre-alignment filtering, if you pick any of those topics, you should read this paper for sure. This is a review paper giving you all details that you would need for the background, for related work, and even for picking the tools that you're going to review. Okay, so if I have such figure that explain the whole mechanism, the whole workflow, it's really walk through the entire process. So you start with data extraction in the wet lab, you extract some DNA segment, you do sequencing, or you download the data from somewhere on the internet. Once you get the genomic data, you do some process, you jump here, you jump there. Now, how would I describe this figure if I'm going to write an overview? First, don't ever jump into any details of each of those steps. Don't directly jump. For example, we sequence the data and then do some analysis and we get the result as a machine learning algorithm or model describing weights and so on. This is not the way to do it. First, you have to tell me what is about this figure describing, for example, read mapping process. Okay, and this process includes how many main steps? 1, 2, 3, 4, 5. So you have to tell me frankly, clearly, don't go around in circles. Clearly, just tell me read mapping includes 5 major steps. The first one is this, the second, the third, the fourth, and the fifth. Clearly, it's really easy to describe. Now, start with the first one. Give me the general idea. Okay, for example, in here, I can see 3 major parts. You can tell me step 1 includes 3 main steps, or we can get the sequencing data from 3 major sources, either by doing the sequencing ourselves or downloading the data or do the simulation. Once you give me the full overview, the overall description of this step, you can jump into the details of that step. For example, you can now compare the 3 steps. Which one better? Which one should I use? I can use 3 of them for downloading or getting the sequencing data, but which one is better? Which one provide the more convenient data that I could use? You can show the drawbacks, the advantages of each of those steps, and so on. Then you can jump into more details. For example, you can tell me nanopore is better than PacBio, PacBio is better than Illumina, and so on. In terms of cost, if you look for size or throughput, then this one will be better, and so on. Once you've done everything related to that step, you jump into the second one. And then exact same method. You can say base calling, it can be done differently for Illumina, for ONT, and PacBio. Hence, it's really sequencing data dependent process. And it can be very expensive for ONT, but for Illumina, it's very cheap because of this and this and this. And if you want to do base calling, you could do it. If you don't want to do it, you can still operate on the raw sequencing data because this and this and this. This is really how you should describe this. I hope you already got the idea how you start describing the background or the overview for the method and so on. Exact same method you should really follow for even your own research. This is not about the course. I'm giving you my experience for the last 15 years of doing research as a PhD student and then working in Switzerland and in the US and then in Japan, Malaysia, Turkey. So this really how you should write your own papers regarding if it is a new algorithm, if it is a review paper, if it is just thesis, and so on. All right, once you're done with the overview, then you could have more sections on the important aspect of whatever you describe in the overview. In the overview, you might be briefly describing, for example, sequencing, how it's happening. If you feel this is a major contribution of those tools, you would dedicate a separate subsection in the method section, okay? So you could have as many subsections as you wish. For example, you figure out that all the 4 tools that you are reviewing, they have one common main component somewhere. They have a component that done some accurate detection of a variation in the genomic sequences. So you would have that separate subsection for sure. You should include it, like you can call it variation detection, SNP detection, whatever you want. And then you describe how it is done in each of those tools, okay? You might see some important component that relate to the performance. For example, most of those tools are implemented in C programming language, or are implemented using this library, or they are implemented using this SIMD vectorization or GPU parallel computation, FPGA, whatever mechanism that's related to the performance. What is the reason why all of those tools are using that component? Okay, it could be, again, library in Python, it could be library in R, anything. You find something really interesting. This is the place where you would discuss anything related to the 4 tools, okay? I give you some questions over here. So once you answer those questions, you will have that section ready. For example, the moment you start describing any main component, you should always start from the goal of that component. That is the first sentence I would see. Again, don't try to add junk details, junk sentences, just garbage where you want to fill the paper and just exceed the 4 pages and that's it. That's not the goal. So always try to have direct sentences. For example, you could start that section. The goal of the component 1, 2, 3, 4, 5 is to do this and this and this. You should be very clear. Don't add moreover, however, in addition to. All those, just we call them junk. Okay, just are there to increase the length or the number of words in a paragraph. Don't do that. Always use direct language. Always use very clear and even very common words. Don't try to use strange or difficult words from Shakespeare time. That will not going to impress the reader, but in fact, it's going to really to sound weird. So try to always use direct language. Always say, in this paper, our goal is to do 1, 2, 3. We are doing the first goal using this and this and this. And we propose to do this and this and this. Directly, don't use any other phrases, something else. The goal should be the goal, right? The objective should be the objective. What is novel should be novel. What is new should be new. So if you have something new, say it clearly. This is the first time to propose this to solve this problem. Very clear. Sometimes I really find myself very difficult to know what is new in this paper. I read the entire introduction, the entire abstract, and still don't know what is new in this paper. And it will make really the reader suffer. It will make even the reviewer might just reject the paper because he cannot understand what is new in your paper. So always try to use very direct language, make everyone's life easier. Say directly, our goal, this work is this. The contribution is this. The key insight is that. The problem that we are trying to solve is this. Nobody can argue with you in this way. Once you describe the goal, what is done to achieve that purpose? So the goal of that component is this, but how we achieve the goal? By doing this mechanism and this method. And now, you should start with the key idea. Okay, we describe how it works, or what is the key idea, or how we achieve the goal. Now, what is the key idea of achieving that goal? Okay, it could be the key idea, a theory somewhere, or it could be an insight that we figure out while evaluating. And so we figure out that those problems or this component suffers from this and this and this. And the key idea is to improve the performance by solving that issue, for example. And now, is this something new? You could, once you have 4 tools, you could say clearly that this tool was using the idea of the second tool. And the 4th tool was using the idea of another tool from very old time. So you can now correlate those 4 tools together. Is there any challenges why someone else before 10 years didn't do the exact same algorithm? Was there some technology limitation, some problem with the data, some problem with the software, with the CPU performance, and so on? And then highlight whatever you want, you see really interesting with that tool. Then give some reasoning why this is the best. Give some reasoning why this is limiting the time, why this is improving the accuracy, why this is doing that. And then give any details you want. I believe if you answer a paragraph about each of those questions, you will have that section ready without any suffer, without any pain while writing that section. Again, you could use ChatGPT, you could use any of those AI tools, but be careful. Those tools, you can use them to organize your ideas, to figure out there is something you didn't think about before. And that is just to open a door for you. But if you copy paste, if you rely on it, if you consider the information 100% authentic, if you consider everything given by those tools as like holy book or whatever, that is wrong. And you might get zero for that effort. It's easy for me to figure out that this is written by such tools. So you are allowed to use those tools just to organize your idea, just to describe, for example, one of the terms that it's first time to hear about and so on. But don't ever copy any text from those tools. I hope this is clear from now on. So just those tools, use them to open some doors for you, but don't use them to write or to copy paste the text from them, okay? Now, everything we said until now, it's applicable for any subsection in this method. I hope this is clear. We spent like 15 minutes just on this section. So just duplicate, replicate, whatever we said about this section, you make it true for other subsection in the same section of methods, okay? Now, sometimes we might give a title for each subsection instead of just saying like improving performance. You could say like this is method 1. That is in the title of the subsection itself. Method 1, and give the description of that method that is in the title, but make it always concise, make it always short, make it always direct to the point. Don't add a lot of jargon or junk words. Don't do that. Always be direct in research papers. Okay. Do you have any questions so far about any of those sections? You have something in the chat. Could you share the title or link of the read mapping review paper you showed? You should be aware about that. We already have it in the slides. So I already asked you to read it. Do you remember when I asked you what caused the sequencing machine to not read the entire sequence of our genome? That is the exact same paper, okay? It's called From Molecules to Genomic Variations, Accelerating Genome Analysis via Intelligent Algorithms and Architectures, okay? You'll also see some other topics, not necessarily only read mapping. For example, base calling, variant calling, sequence alignment as well. You'll see it somewhere underneath read mapping. You will see indexing, you will see sequence alignment, you'll see many more topics in the paper. It's a bit long, but it might be useful for you. Okay. Any other questions? Please raise your hand if you are still with us and you can hear me. Please use the tool in Zoom to raise your hand. 1, 2, 3, 4, 5, 6, 7. The other people went for sleeping, went for a walk, exercising, having breakfast. We have 8 now. We still have 1, 2, 3, 4, 5, 6 more. Please raise your hand using the tool in Zoom if you can hear us. Right, we have 5 more, 4 more, 3. We have thumbs up, which is great. Okay. All right. Yeah, thank you. So Now, by doing that, you're already done with 70% of the review paper. It's really that easy. That includes really 70% of the grade and 70% of the paper itself. Now, what's remaining is the easiest part, which is the most fun, I consider, the most rewarding part, and the most enjoyable journey, which is just downloading the source code, try to run. You will see a lot of technical problem on how you solve this package, how you download that outdated tool, how you'll compile, how you'll do many things with the tool. But that is something really nice, especially that most of you with a major of computer science. There's a math, there's biology, there's chemistry department student, but I assume also they are interested in running tools and doing some comparison. Now, once you download the source code, you compile, you need to figure out what kind of data you could use. Now, for the data, I don't want to make your life difficult. I don't require you to run using really huge data. If there are like 10 data sets, just pick one of them. Don't worry about what you are going to pick. As long as this data is used from some other paper, it's already used by other tools, you can use it. Don't invent your own data. Don't assume something else. It will be tricky for you. So just use one of the data sets that exist already in other papers. It might be available publicly. It might be on GitHub. It might be on NCBI databases and so on. Once you figure out what data you can use, if you still cannot figure that out, you can reach out to me directly. Just ask me what kind of data I can use with this tool. I can pinpoint you to some specific tools or data that you can use, okay? Again, if you have some issue with the machines that you are going to use for running the tool, let's discuss it. For example, you don't have Linux. For example, you have very low capacity and storage, very low main memory. Any of those technical issues, just discuss it with me, okay? We will try to find a workaround. And then once you have the data ready, the tool ready, now what is the main important point is to decide what you are going to evaluate. Are you going to evaluate accuracy? Are you going to evaluate speed? Are you going to evaluate some discovery? Are you going to evaluate some other important stuff in the tool? Then those probably you will spend most of the time trying to figure out what you are going to evaluate, okay? Now, how we could know those information? By simply just replicate whatever evaluation they have in the tools that you are reviewing. For example, if you are picking Minimap 2, just go to the Minimap 2 paper, try to look what kind of evaluation they have done. They have done accuracy and speed. Okay, done. I'm going to do only those two. This is how they evaluate, and I'm not going to invent the wheel. I'm going to use exactly what they were going to use. And okay, for speed, how I am going to evaluate that? You need to read whatever they describe in their paper. They describe it using this and this algorithm, or this and this benchmarking tool to evaluate the performance, or they use this command line in Linux to measure the execution time of the tool. So you would use exactly the same thing. You will do the experiment, you will get some data, some numbers from the measurement, and now you need to have those numbers in a table. Table, always the best way to describe numbers, okay? When you do a table, you would do something, let's remove the white space over here, some white space from here. When you do a table, you will build the table yourself, regardless how many columns, how many rows. The caption of the table should be above the table. The title of the table should be above the table, okay? And the way you would do it, you will have table, you have to write table yourself, and then space, and then the number of the table, and then this 2 dots, and then space, and then you start with the title. As clear as that, okay? Now you'll have the table. If you really need a footnote for any of the terms in the table, for example, you want to say that this is not in gigabases, this is in terabases, for example. It's always better to have the unit inside next to the number, but sometimes you might say something about that number. So you would add the number over here as superscript. You would do it, you highlight the number, for example, and go to format, text, and then choose as superscript, okay? And then you would do the same thing below the table, and then add whatever note you want on that, okay? That's for the table. Now, if you want to add a figure, of course, this is what we call the raw data, the number that you got from the results. Now, beside the table, you need also the figure. So you will do both of them. Although on real paper, we'll do one of them and the other will be added to supplementary material. So the raw numbers normally in supplementary material, and you will have a figure. But in your review paper, please include both of them, because I'm going to grade you based on the numbers that you got and how you visualize those numbers. Now, how you'll add a figure. The best way to do it in Microsoft Word or in Google Doc is to add a table. You need to add a table of 2 cells. The cell at the bottom, you will describe the caption of the figure. So you will say clearly, figure, space, 1, 2 dots, and then the title of that figure, okay? This is how you should do it. In here, you will add the picture. Whatever figure you have from Excel, from Python, from MATLAB, whatever figure you use or software, you include the picture over here, okay, in this cell. Now, once you do that, you highlight the table. You highlight the table, right-click, table properties, and go to, I think, either cell or color. Yeah, maybe color. Yeah, table border, and you have it as a white, or you make the size as 0. Both of them will have the same effect. Either you include the border as a white, or you have it as a 0. Okay. Now you have the figure in a table, and it's not shown. Why we did that? You always figure out in Google Doc or Microsoft Word, once you add some text, the picture of the figure jump to somewhere that we don't know where. Sometimes it's hidden inside the footer over here. Sometimes hidden to the left side, to the right side. This will not be an issue in Overleaf most of the time, especially if you use very good package for the figure and the table. So the way we solve it, we have to have it inside a table. And this way, it will never be randomly placed anywhere else. If you place the table here, it will always stay here. It might be shifted a little bit down or up, but to stay as whole component somewhere, okay? This is how I do it myself as well. All right, so this is how you do the figure, this is the caption, and this is where you place the picture. Now, I include also for you some questions that if you answer, you will have the evaluation result ready for you. You don't need to suffer. So please read these carefully, but what I want to include, this a very important subsection. You have to clearly read it and describe your result the exact same way, Don't use some other ways. The exact same way you should use when you describe the result. That will make your life easy. In 5 minutes, you could finish describing the one figure, okay? I can guarantee you that. I tried it myself many times. And if you want an example on this, I will always go for this paper because easy to read. I'm going to post it in the chat. This is an example on how you can follow describing any of the algorithm. So you can go, for example, on this section. This is in the results, okay? And you can see how I follow a method on describing those results. You can see figure 3 here where I describe figure 3 and what I say about number of observation. We make 4 key observation, 1, 2, 3, 4. And under each of those, I start describing the exact result. All of this is already described in this. I really spent some time until I figure out with this document. Again, this document is just a summary of my own experience. You might find another way of describing the result, but for this course, please follow this method, and then it's up to you if you want to follow it in your research or some other method. That's up to you, okay? But this is something really nice, something really clear. Anyone reviewing your paper or reading your description will be happy on the observation, how the way you extract them from the figure. Okay, the way how you highlight outliers, what makes this better than the others, and so on. Now, one important, very important, actually, very important way of describing anything. Do you remember when I told you to go to the high level and then jump into the low level details? Also, when you are enumerating some stuff, if you are saying this method consists of or includes 3 main components, don't ever use something like this. Read mapping includes indexing step, which does blah, 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 blah. Okay, dot. Moreover, it uses a step called sequence alignment, which does blah, 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 blah. Okay, don't ever use this method. If you are sure that read mapping includes 3 main steps, you have to say that. That is the high level way of describing it. Includes 3 main steps. You can have 2 dots or comma and then describe X as the first, Y, Z. Here, since this is the last, you add and dot. And then the XX component doing this, and it consists of this and this and this and this. And then the Y component, this and this and this and this. Optionally, you could add numbers here, 1, 2, or first and second, third, fourth, lastly, and so on. But don't ever jump into the first step directly and then try to add. Moreover, there is another step. In addition to, there is a third step. However, there is another step. Don't do that. That is directly, you lost the flow of the story that you are describing. Okay, because I lost counting. How many of them? There's moreover. Oh, this is one. However, there's another one. In addition to, there's a third one. I don't know what. That you are giving them hard time to figure out how many components are there. Okay, so tell them in frankly speaking way, just there is 3 main components. 1, 2, 3. The first one is this. Second is this. Third is that. Okay. Those are some of the really hard time I had always with the student on how we describe any mechanism or any way, okay? So always try to go from high level all the way to the low level details on how you describe any component. I already gave you the paper Sneaky Snake as one of the example on how you can write. So you can, whenever you feel any question or you're not sure about something, always jump to that paper, see how I describe something, and then you can mimic the exact same method, or you can follow the exact same way or flow I have in the story, okay? That will be it. Then you have a conclusion. Conclusion is different from the abstract. Abstract, you are describing what are the most contribution that you did, what is the story, what is the application that you are solving, what is the problem, how you solve it, and what are the main results. Those are the 4 main components in the abstract. So what is the application you're working on? What is the problem in that application? How you solve it? And then the key result that you got from the evaluation. That's abstract. For conclusion, don't repeat what you have in the abstract. That is really wrong. This is not the idea of the abstract, of the conclusion, sorry. Conclusion is something where you discuss some stuff that are more important for the future work, okay? Although it's called conclusion, but you are not summarizing the paper. You are not summarizing the abstract. You are not rephrasing the abstract. Don't do that in conclusion. In conclusion, you are going to discuss, you could repeat the application you are working on, the problem you are solving, and then directly jump on what are the drawbacks of your algorithm. You propose something nice, the results show something really interesting, but you might be missing some of the component. You might say clearly that this component suffers from this and this and this and this, okay? You show the drawbacks of yourself, so that's very important to show really what are the most important drawbacks that you are expecting to have. We have a question, I think, from Kendall. Please feel free to speak up, open the microphone and speak up. Or you can type in the chat if you have a question. All right. Yeah, please go ahead. Ask the question.
Professor, I have a question. Yeah, thank you so much for like this paper outline. But I had a question. Like sometimes, like the results are not as you expected, right? Like suppose you so suppose we came up with a technique, it worked well, then it's so we can write those results. But sometimes the results not go as expected, right? So
Yeah,
how to present those findings in a way so that like those are also insights, right?
very
But
nice question. It's really very good. So basically, when you have some bad results, you might be expecting those in advance. So you might be already discussing this in the method section, that this tool might be suffering from this because they are using this method rather than the other method. Or we already know that this tool can handle only short reads, but the other three tools that you are reviewing can handle long and short. And now when your data is long reads or mix of long and short, as in ONT, for example, then you might say something about that in the result, and you don't need to elaborate because you already explained this and you expected in the method section. You're already mentioning that this suffers from this and this and this. And as a proof, you already show in the result that this is true, okay? In this way, it's 100% clear, okay? Sometimes you don't expect this outlier performance in advance, and you will see it only when you evaluate, and you cannot explain why that is happening. That is also fine. You can clearly show in the result that we have outlier. Like outlier means it does not comply with all other data set or all other data point in the figure. So for example, always we have increasing performance when we increase some parameter. Whenever we vary the read length or something, the performance is always increasing, okay? Except at one point where it starts dropping. And at that point, it's very interesting to know why at that point only it started dropping, okay? Sometimes you don't know the reason, so that's fine also. You can have just one paragraph in the result saying that we note that at this point, the performance started dropping and we don't know why. We cannot justify it. That's how you describe it, okay? Sometimes you could ask the author of that tool, why at this point I'm getting this performance? You could raise a ticket at GitHub and the tool itself and ask the author, I'm getting this performance. Is this something expected? Sometimes you could check some forum on Google, like Stack Overflow or any of those forum, and see if someone already reported this before, okay? You could ask the author directly over email, I'm getting this and this and this. Is this expected? Or you could ask me, you could ask someone else, like professor working in this field and so on. That looking for the explanation. But if you cannot provide, that is fine. Don't worry about that. Of course, you cannot digest a topic in 2-3 months and be an expert where you justify what is happening. Okay, that's fine. But that's a great question.
got you, Professor. Thank you.
All right. Do you have any other questions? Okay, now we have about 10 to 20 minutes. Maybe we can use that time to go over the tool. I think we are done with the outline. As I told you, conclusion is about drawback, discussing what other people could extend your work. What are the things that you lack or your tool lacks? What are the things that you feel in the result they were like a drawback or fall or a failure that someone need to address in the future work. And then some other optional sections, sometimes some journals require them, but you don't have to include them, except the code availability. So you have to include the code or the exact version of the tool that you were using and how you run it and what kind of command line you perform, how you extract the execution time, the memory, whatever you were evaluating. So give me a lot of details on how you run the tool, how you download from GitHub, what kind of command line you use, and so on. I will give you more details about reproducing your experiment and your result and how we do it. Okay. That's almost it. It's really easy job. Don't worry about it. If you handle this review paper gradually, rather than waiting until the last month and then you start to write everything, you will feel really overwhelmed. But if you do gradually, section by section, for example, you try to understand the background first. This is the easiest to write. And then you write something in the introduction. You jump to the method, try to summarize each paper, how it works. Just we want the main idea, the main algorithm. What is the key idea they are proposing? That's what we need. You don't even need to read the entire paper if you wish. Once you finish the method, you go back to the introduction, try to improve some stuff over there, and then the evaluation, okay? So probably the background and the method will take about a month if you are working like 2 hours a week or so, not continuously, but you can finish it in 1 week, the 2 sections. Introduction in 1 hour you can be done because there is no details, just a brief description of each of those things in the paper, including the evaluation. Evaluation would take the most time. I would expect 1 month just for the evaluation because I know there might be some technical issue, but also that might be really straightforward. You might not face any problem at all, okay? So 1 method for the evaluation, 1 method for everything else, I would say, okay? Please follow the exact same flow I have in the outlines. Please follow the same method. Please be clear in your way of describing the text and try to have a nice story. Imagine you are explaining, I'm sure some of you are already TA or lecturer even, teaching some courses. So please follow the exact same story as if you are explaining to students. You always go from the high level to the low level, jump into the details, try always to give a figure to explain an idea. Sometimes you are lacking words on how you describe something, but when you draw a figure, everything will be clear, okay? Let's not spend more time on this. I think we cover a lot of things. Now let's go back to iCollege, leagues from next year's, okay? All right. Enjoy the rest of the day. If you have a question, we still have like 10 minutes. We can take them.
Hi, Professor.
Thank you so much, everyone. Enjoy the rest of the day. It's sunny and very nice weather. So take this opportunity to walk around, to exercise, to have fun. And we'll see you next week with the next lecture.
Thank you. See you next week.
Thank you.
Thank you.
Bye.
Thank you.
Bye. Thank you.